Cool, so thanks a lot for having me. Again, I'm Mike, and I'm the head of our platform team at Famous, and kind of what we specifically work on is the rendering engine for our JavaScript architecture. And one thing I wanted to talk today about is mixed mode, and mixed mode to us is kind of client-side compositing for the web. What it is exactly is it's a feature of our new rendering engine that allows for like the complete unification of DOM and WebGL. And by unification, I mean there's a single API, there's one coordinate space, there's complete layer compositing, and there's no user-side hacks. So one API, it's the idea that I move things around in space, and all of these things affect both DOM and WebGL. I don't actually have to care about these, like how they fit into the system differently. One coordinate space, I'll talk to more of it later, but there's a pretty different sense of spacing when you do WebGL content versus than when you do DOM content. Compositing, what I mean by compositing is if you take a three-dimensional scene, so like my hand here and my hand here, what it does is compositing is the way to understand where things are in three-dimensional space, where the camera is, and flatten them into such a way that it looks correct as projected onto the screen. And we want to abstract all of this away from the user to have to deal with it. So again, this is kind of what compositing is. So the question is, why would anybody even want this? Is this a feature that no one really wants? What is the point of trying to merge these two things? And to me, it's because the web is becoming a lot less about pages, and it's becoming a lot more about full experiences and applications, things where it's not a big piece of paper scrolling. That said, there are a ton of use cases where that is the best way for your the medium that you're, and the content that you're trying to show. So if you look at something like Reddit, Reddit is the perfect example of something that needs to be in a document. You have all these news stories that are listed one by one by one, and you can scroll through them. It's really easy, it's really simple, and people want to view this kind of content in list form. Similarly, a lot of other news outlets like BBC have pages where it makes a lot of sense for them to just list everything vertically and have users scroll through. It's like a really common interface, and it makes sense. There's no teaching the user how to do something. Similarly, ESPN, they'll have the bar at the top, the navigation, but then the bulk of the content is in a document. So what are the benefits of this? One, it's familiar for users. Users know how to navigate this kind of application. It's familiar for developers. There's like no tricks. This stuff has been around for years and years and years. And browsers were actually literally designed for this particular purpose. There's a reason it's called the document object model. It's the idea that all of our CSS, all the way we do stuff, is based around the idea of positioning a document on the screen. It's compatible. It'll run everywhere. These things are super, super old. And one of the big benefits for me, too, is easy navigation. So like this is a little picture I drew of me on the couch browsing Reddit. Like I have my laptop in my lap, and I scroll with my two fingers, and I don't want to have to like navigate this big space. I want like a little bit of scrolling to get me everywhere I need to be into my application. But this is also not the best use case for a lot of things. So if you go to like the website for the movie Birdman, they have this really nice art cinematic with like meteors falling down and different typography when you type, and these all pop, and it's all written in WebGL. And then there's a lot of things like these Chrome experiments out there where this particular demo, what they did is they have a globe, and the globe is completely mapped to be like correctly sized, and it shows the different arms trades between nations. So you can say, all right, what is the how many guns and ammunition go between the United States and Canada? And you can see the lines and where they're coming from, the depth, and that's something that only really, really makes sense when it's not in a document form. It gives it a lot more expression because you're able to use three-dimensional space to your advantage. Similarly, there's this one really cool Chrome experiment that is the galaxy, and you literally pick a star and you zoom into the star and you get to see all the properties about it. And this only makes sense because spatially we want to be able to see the galaxy in terms of like proportions as to where they are relative to each other. So there is some legend that says 10 pixels is 1 light year away or something like that. That can accurately describe what the galaxy is. And again, something like this does not make sense to be used in a document. So what are the benefits of heavy WebGL use? One, it's beautiful and inspiring. You get much, much better performance than you do with the DOM. You get shapes. The DOM is really, really good for rectangles, and that's about it. But you can do toruses, you can do pyramids, you can do triangles, you can do any kind of shape. And you can do arbitrary 3D models also. So I can import like a Coke bottle or an elephant OBJ for a game or something. And now I have the ability to create content on the web that's not just panels on a screen that are moving up and down. So the real thing is that you saw a few examples that used the document to their advantage, and you saw a few things that used WebGL really heavily to their advantage. And the idea is you want to use the best technology that represents your content. So if you have content that makes sense in a document, that's fine. But there's also content that's better represented in a non-document format. But the one thing is that it's not just use WebGL for like super high experimental stuff and artwork and use DOM for documents. The DOM can work in a 3D environment. It's more than just an overlay. If you looked at like the prior examples with all the Chrome experiments, there was DOM and there was WebGL in all of those scenes, but the DOM was only ever used as an overlay that fits in front of the WebGL. There was never any layering between the two, and the DOM is capable of a lot more than that. So here are some examples to help show like kind of what the upper limits for what the DOM can do in terms of just like performance. So here's an example somebody on our creative team made of an ad. And this is all DOM. So one more example of just something that, that can be done in the DOM. This is my personal website, just something I had to test some stuff, but this is all DOM. And you get the ability to manipulate space and work in 3 dimensions just by using DOM. And so now the question is like, well, this looks really good, but it still comes short in a lot of ways. DOM, you're going to hit performance issues as soon as you hit a large number of elements on your screen. The browser's just not handling, it's not designed for the case of thousands of moving divs on the screen all at once. Also, the DOM does not make really good, or browsers don't make really good use of the ability to change color frequently. When you change color, you're causing repaints over your entire screen. And then you can't do certain types of blurs, you can't do post-processing. All of these types of effects that you see in games and you see in other forms of medium are kind of not at your disposal. Also, you can't do shapes. You have squares and you have circles. You can do CSS arrows and you do stuff like that, but that's more of a hack than anything else. But you're really, really limited to the amount of different shapes and primitives you have, and even just the level of detail. I could have a square here that has some gradient on it, but I can't make a gradient that reacts over time based on when I click it, and that's something that WebGL does give you. So again, why do these flaws exist? It's because the DOM was not designed to do this. Browsers are optimized for scrolling pages of content. They make a lot of constellations so that when you scroll a web page up and down, that image in that video looks really, really crisp. And because of that, because of the ability for them to scroll up and down and make that really, really performant, you take hits elsewhere. And again, this is kind of like the roots are in newspaper style DOM information. So where's the DOM better than WebGL? So what we want to do is we want to be able to take the best of both of these rendering targets and use them into a single API. So what is the DOM really good for? The DOM is really good for CSS. CSS is iterating very fast. They're getting a lot of new stuff. And you can style really, really nice looking DOM with it. It's got a built-in eventing system. It's really good for search engine optimization. It's compatible. It's everywhere. You can have forms links, and there are standards that try to get followed. And what does WebGL have? WebGL has performance gains, color changes, different types of shapes, like I was mentioning before, 3D models. It's more expressive. And something that's also nice is that it's more familiar for graphics people that are not involved in the web currently. So this sounds good. Let's think about what we want to do to like make a mixed mode rendering system and like what the requirements of this would be. So the first thing is we need one API to roll them all. We need the exact same coordinate space, so 20 pixels to the right means 20 pixels to the right. And we need proper layering, which means we need to have DOM be able to be in front of GL and WebGL to be able to be in front of the DOM. And this, again, needs to be abstracted completely away from the user. So step one, let's create a single API for the DOM. So what we want to do is, because we want to make use of three-dimensional space and kind of work the way WebGL kind of works, the document object model is not the way we want to do layout. We want to position everything in terms of 3 dimensions. And the abstraction we use for this is something called a scene graph. And basically, it's a mutable graph of nodes where your parent tells you hierarchical information about where you are in the scene. So if I'm a child of a parent node, and my parent gets translated to the right 20 pixels, I am also translated to the right 20 pixels. So that begs the question, what other type of information is hierarchical? Like what is preferentially treated in our system so that we can get this motion between DOM and WebGL synced? So we have transform, so that's translation, rotation, scale. There's size. So I can set size in terms of pixels. I can say I'm a 50 by 50 by 50 box. Or I can say, all right, I'm 50 by 50, but my depth is half of my parent's depth. And then also opacity. We want opacity to chain down. So if my parent gets opacitated, I also need to be opacitated. So because of this information, we kind of have everything we need to define where something is in three-dimensional space. And that's kind of the key to everything, is just by having these 3 properties on every node in the scene, we can define where something is in space. And that's kind of the crux of the API. Is that you are taking these, if a node has a point in space that determines where it is, and it has a size, so that gives it pretty much a cube, you're essentially positioning these cubes in space to make your application. And the only thing left to do from that point is we need to add the ability to draw. So the idea is that we have these renderable components that attach onto nodes, and again, nodes are defined as a point in space, a cube. So if we just give the node the ability to understand how to draw or send information on how to draw, then we're kind of all set. So if we take a look at this example right here, you can see like the first line, we're going to create our scene, and we're going to add a brand new node. And then the next few lines, we're going to position the node. We're going to say, all right, you're 250 pixels by 250 pixels by 250 pixels. We're going to move you to the center of your parent. Your center is going to be at that point, and your origin for your rotations is going to be your center. So, and then we also attach a component that's responsible for rotating the thing around the y-axis as time moves on. So this is all the code to set up this like fictitious cube in space rotating. And that's all we need to do. And now from here, what we can do is we can attach components to these nodes to give them the ability to draw. So here we have this node that's spinning, this like invisible node spinning in space. And we're going to say, all right, I'm going to add a DOM element to it, and it's going to have a background color of red. And I'm going to add a mesh to it, and the mesh's geometry is going to be a sphere. So what this ends up looking like is exactly kind of what we would think. We have a single node that's spinning, and on this thing is both WebGL content and DOM content. I'll get to more about kind of the coordinate space and why the layering is working later on, but you can see that like this API really abstracts away the idea of positioning content from the actual drawing of the content. So then the next thing we need to reconcile is the differences in coordinate systems. And unfortunately, there's a lot of differences. So for the DOM, the origin of the DOM is the top left of your screen, and it's the width and height of the screen in pixels. And the transform origin of all of these DOM elements is the top left. So that's why when you put something at identity, it's up in the top left corner. Its top left corner is up there also. For WebGL, it's very different. The outer bounds of the screen are -1 to 1 in width and -1 to 1 in height. And when I throw something in at the origin in WebGL, the center of that object is on the center of the screen. So what we need to do is we need to have the ability to treat these two systems the exact same way. So for example, kind of makes sense. If I have a screen that's 1400 by 900, and we're going to take 100 by 100 square to the right and throw it 50 units down and 100 units right, the DOM and the WebGL are going to be miles apart. So how do we reconcile this? The first thing we need to decide is what we decided to do is like, what do we want the API in? Do we want the API to be in this clip space, this -1 to 1, around there, or do we want it to be based in pixels? And we decided to go with pixels for a few reasons. One, developers know it, it's easy, and the real reason is that it makes 2D layout so much easier. When you're using -1 to 1, it's really designed for like 3-dimensional environments, and it's not designed for something that you need pixel perfect design for on different size devices and whatever. So we went with, the origin is going to be up in the top left corner, and our entire API is going to be in pixels. So do it all in pixels, and then we convert it for you. So the idea is that you can treat your application and write it all in pixels, and even though WebGL doesn't want that kind of information, the rendering part that you don't even deal with can do the conversions for you. So what we have is we've broken up the system into two parts. There's the application part, and there's the renderer. So the application part does all your business logic, your layout logic. It has the nodes. It has all your renderable components, kind of the code you guys saw earlier. And then there's the renderer. And what the renderer does is it takes draw commands that are generated by the nodes and the components of the nodes, and it turns them into the actual pixels that get drawn onto the screen. So this is kind of like a simple diagram of our architecture. Basically what happens is we have our render loop, which in most cases is something like request animation frame, and we pass like a frame into here. The frame lets the Famous engine know that it needs to update a bunch of stuff, updates its clock, and tells the scenes to update. What the scenes now do is the scenes go through and they say, okay, did anything change for me? Am I red instead of blue? Did I get translated at all? And it goes through all the nodes in the scene, and anybody that has diffs that they need to push sends all the draw commands back over. So all of this draw command information goes back through the compositor, and from the compositor can decide, okay, this is information that the DOM renderer needs to know about, or the WebGL renderer needs to know about, or something that they both need to know about. So from here, we can do all of our stuff in pixel space, and then when it gets down to the WebGL renderer can be the one that's responsible for saying, okay, I know what to do with this. The screen is this big, and my transform is this, so therefore I can handle this for them. So again, if we consider the world transform and size in pixels, and by world transform I mean like physical place in reality, like regardless of camera, regardless of thing, if we're trying to think of our applications as 3-dimensional scenes, like where they are in space. And again, it's the renderer's job to make the medium-specific adjustments. So the DOM does have to make some adjustments too, because we have DOM nesting now, which is really great. You can use CSS, and you can use the bubbling that nested DOM gives you for free. But basically the idea is we need to account for the parent's transform. If in world space I'm 500 pixels to the right, and my parent is also a DOM element, and in world space he's 400 pixels to the right, my one that I write to the DOM only needs to be 100 because my parent's already taken care of 400 for me. WebGL needs to make very similar adjustments. They need to convert the size to clip space, so -1 to 1. They need to convert the transforms to clip space, -1 to 1, or yeah, -1 to 1, and then also account for the move of the top left origin, from the middle to the top left of the screen. So the third step in this is the proper layer composition, and this is kind of like the biggest part of kind of what we do. So the thing is that we have two elements that we control pretty much. So you put a little Famous application somewhere, and we have a canvas where we put all of our GL content, and we have a div where we put all of our DOM content. So how do we get it so that DOM can both be in front and in back of the WebGL? It seems like it couldn't be possible. So the big trick is that we always have our canvas in front of our DOM content. And because we're doing everything in terms of world space, we know where every DOM element is, and we can tell the WebGL renderer to add a completely transparent plane to the scene at the exact same location as the DOM element. So what this does is this pretty much creates an invisible plane that is referenced in the WebGL render so that it can cut out a little spot for us. And so basically the thing is that you don't ever have DOM in front of WebGL, but what happens is that we cut out a little scene in our WebGL scene so that you can look through, see the DOM element there, and it lines up so perfectly that you don't even know that your eye's playing a trick, and you can't even tell that it's like actually layered behind it in the DOM. So here's some of like the cutout stuff in action. So this is a scene where everything's working, just some context. So we have a little light here, we have a GL plane, and we have a DOM element that's right here. So if we move this around from where I'm perspective, like imagine you're the camera, this looks correct. Like if I turn this the angles are right and everything is layered the way I would imagine it to be. So let's say we didn't have cutouts on, so that there was no cutting out of that invisible plane for the WebGL scene. So you can see that like this looks similar. You know, the light, this was in front rotating, and you have your plane. And when I go behind it, still looks really, really good. But the issue is, I'm not cutting out from there. So even though the pink div is technically in front in world space, we're not cutting anything out of our plane to account for this, which is why it looks like it's behind. It looks like it gets hidden behind. But even though we know that it's in front in terms of world space. Here's one more example of kind of the exact same demo, but this shows it pretty well. So we have an invisible div right now. And we have the same thing. So imagine the invisible div is right around here, right? What you can see is this is exactly what's happening, is that we're just cutting out a plane inside of our WebGL scene, and now you get this complete interaction of doing DOM and WebGL in the same space. The user doesn't need to know at all that these are like technically not supposed to happen this way, and we can abstract the differences between the two rendering mediums away from the user, so that the user can just focus on like, okay, position everything in space in a consistent like definition of what layout in space is, and then just draw the nice things with the correct tool. So we also have a few examples of putting it all together. So these are some like of our mixed mode demos that show what you can do with this. And again, these are demos, but everybody, you guys probably have the JSConf website open on a tab in your browser right now. Well, I have a MacBook with the JSConf website in here, and this is completely navigatable. And I can look through this, and this is all DOM. I can check the schedule, and I can even navigate backwards to it. And it's really cool. And that's the nice thing, is that like I wouldn't want to do that web page again in WebGL. I wanted to use that web page for what it is, but I can do cool things. Like I can put it with this MacBook OBJ. I can put a plane on top of it that has some nice shear on it, so it looks like there's like lighting glossing off of the screen. And being able to take the best of what both these technologies has to offer is a really, really useful thing. Here's an example that we've had for a while now. Hold on a second. Cool. So if you look at all of these things, they're completely DOM. I can highlight them, I can select them, I can copy paste everything. That's really nice. But I can do really cool sparkle effects with them and do stuff I couldn't do with just the DOM. Yeah, these could probably be images for now, but you could imagine these were like more glowing and particle effects and stuff would come out. And the user doesn't have to think about how to marry these two. They just already existed the exact same coordinate space. And then the last example of this is something that is completely DOM only, but just kind of shows the idea more along the original point I was making, is that there's a lot of content out there that is just not a document. And to think about something as a document is like a really inherently wrong way to think about the problem space. So if I have an image carousel of things and I want to throw things like that, nothing about this is document. The way I thought about this when I was building it is, okay, I have a little window, right? And what I need to be able to see are the arrows, the dots, and the middle content. Everything else I want to just put over here. And what I ended up using is some physics simulation where I move some springs in and things from outside of the screen come in. So if I take a look and I tilt this thing back a little bit, you can see this is actually kind of what the application is. And you get a better sense from working like this, in my opinion, of kind of what you're building and why it's easier in that you can think of applications as just like a small little window into your scene, and you can hide stuff behind your head, and you can do really cool stuff like that, but have the really easy ability to kind of almost work with something that's more tangible than just a document, and the magic rules that CSS layout have to give to you. Cool. So back to this. So what are the current limitations of what we have? So unfortunately, right now, we only support rectangular DOM. And that is not that bad of a thing because it's a completely fixable solution. So what we have right now is that the cutout we make is a complete rectangle that is based around the size that you have defined through the thing. What we're not listening for is, let's say you have a DOM element and the DOM element is there and its border radius, 25, 25, 25. What we can do is we can apply custom shaders to that cutout mesh to mimic the CSS property so that that gets shaped properly. Also, we currently only work with opaque DOM. So if you think about it, one of the issues is that we're doing a full cutout for WebGL. So if my div is half translucent, I'm actually going to miss anything that was rendered back behind it that the cutout was occluding. So what we need to do is have a second layer of WebGL that does all the color math for us, so that we can pretty much fake the idea that there's another layer there. So one thing that was really good about this project was we got a chance to re-architect a lot of our system and make a lot of improvements, and as such, we had a lot of happy side effects. One thing that's really nice is because the entire system is completely based around these draw commands that go from your components on your nodes to the renderers, this code can be completely run in not the UI thread. So we can take all of your application code where you create your scenes, you create your nodes, and do all this stuff, and I can throw it into a web worker. And we have a build working where you have all your web worker code, and then it sends all the draw commands to the UI thread, and that keeps your UI thread just a very, very thin client that doesn't have to do a lot. Right now, the performance benefits of web workers is kind of minimal. I think there's probably a use case out there where people could make use of it, but the technology is only going to get better. And it's an abstraction we really wanted to keep for a few other reasons. Another reason this kind of stuff is good is we also had ways where I could run my entire application as a node server, and I could pipe through socket messages to my thin client just what the draw commands were. So now that's really, really interesting. Imagine your ESPN, and I have a scoreboard somewhere, right? I don't need to have all of the client-side logic for how that scoreboard works. What I can do is I could just have the renderer over there, and the renderer is getting all the draw commands, and all of the complicated logic about what needs to be there happens. And once every hour, it'll be Cincinnati Reds 4, and that's the only difference that needs to happen as a result of these changes. So something else, So some of the next steps that we're considering taking with the project are render to non-web technologies. So again, one of the benefits of this whole thing is that it's completely based around draw commands. So what if the compositor wasn't compositing for DOM and WebGL? What if you used components that output to OpenGL commands, and the renderer was an OpenGL render? So you could have this completely JavaScript pipeline, write your application in JavaScript, and it's generating commands for a native OpenGL application. Also, possibly port to ASM. Fast math is fast. No garbage is good garbage. And it also opens a way for non-web people to build get their feet wet into the web. So if you can write Haskell, if you could write Python, if you can write C, you can write all your code, compile it down through a compiler to LLVM bytecode, and then we can eat that LLVM bytecode and just shove it in and get stuff rendered on the screen. So there's some of the things that we're kind of working towards. So in summary, I think the big thing is you got to think outside the document. There's a lot of cases where the document is the right thing to do. Your content really is newspaper style content, but it's not for everything. 2D layout is a subset of 3D, so let's define the world in 3 dimensions. If I need to do 2D, it's about moving something here and then just working in 2 dimensions. You can make that adjustment very, very quick by shrinking the amount of Z you use. And then I think something else that's really, really nice is the idea of abstracting away the rendering mediums. What the transform and the scene graph give you is it gives you the ability to think about points in space that are completely agnostic as to what I'm rendering to. These are just mathematical concepts that are pervasive and will always exist. And if you think of applications and application architecture like that and UI development like that, it's really easy to switch in what the drawing bits of that are. And again, thin clients give the flexibility to the web. If you're not having full client-side code and you're just having a render on your front end, you can do a lot of cool things. You could do server-side rendering, you could do web workers. You can do a lot that, that currently isn't possible with a lot of things where you're just, manually touching the DOM, and your entire workflow is you grabbing DOM elements and manipulating them yourself. So thank you guys for hearing me talk. Feel free to email me at mike@famous, and I don't really have a website, but if you want my little demo, check that out also.